Welcome to the point slope form video. Today we looked at finding equations of a line in slope-intercept form. So slope-intercept form has the slope in it and the intercept. So just some examples similar to today. If we want to use algebra or algebraic reasoning, if we have 2 points, obviously the first thing is to find the slope. So we do the change in y over the change in x. And so we're going to do 9 minus 2 over 4 subtract 3, which is going to be 7 over 1, or just 7. Once you find the slope, so step 1 was find the slope. Step 2 is to plug the slope and x and y into y equals mx plus b. And so I'll just use a different color. Since I know the slope is 7, I can put the 7 in for the m. And I know an xy, 3 can be my x, because it is an x, and from the same point, 2 is my y. And then I just don't know b, so this is where I can solve this equation for b, just like we practiced solving equations a few weeks ago. So we have 2 is equal to 21 plus b, if I minus 21 from both sides. B is equal to negative 19, so now I know that my equation is 7x minus 19. Oh, that was the third step, to write the equation. Sorry. Write the equation. Okay, once you've solved for b, your y-intercept. Also, another example from class, we could do find the equation using a table. So again, we still have to find the slope. And it's the change in y over the change in x. So we're going to do, in this case, negative 8 subtract negative 2. Those are my y values. 4 subtract negative 2. Those are my x values. Those become big plus signs. So we have negative 6 over positive 6, which is just negative 1. If I go make a table, I know that I have to have negative 2 in my table, negative 2 and negative 2. This is x, this is y, and I have to go up to positive 4. So negative 2, negative 1, 0, 1, 2, 3, 4. And at 4, it's negative 8, and my slope is negative 1, so I know I'm going to go down negative 1 each time. So this is going to be negative 7, negative 6, negative 5, negative 4, negative 3, and there I am, right in order, negative 2. So I know that my slope is going to be, when x is 0, what is y? So here's my, my y-intercept, my b, and my y-intercept. So my equation for this one, here's my slope, negative 1x. Here's my y-intercept, minus 4. And then we've looked at some graphing a little. I just did want to pull a graph up here quick. Oh, that's much too big. Thanks. Oh my gosh, sorry about that, guys. Well, now it's being fussy. Okay, there we go. If you can't fit this graph on, just do a quick sketch for yourself. If I put the point negative 4, negative 1, I have the point the 6, negative 7 is going to be down to there, right? I want to find the slope, and I can do that just on my graph, remember? So, just a minute. Hold on, guys. I gotta. Okay, guys. Sorry about the interruption. I think we are about to find the slope. So if we went down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like down 6 and over 10, which we would reduce to, those both can be reduced by 2, so negative 3/5 is our slope. And it's not very clear, but I wonder if the y-intercept is about negative 3.5, and this can be the one problem with estimating on a graph. So you would have y equals negative 3/5 x minus 3.5 as our y-intercept. So these are sort of all the different methods we looked at in class. What I want to introduce to you today is the point slope form of the line. So rather than having the slope and an intercept, we have the slope and a point. So this is something new for you. So the point slope from the line is y, and that's just like the y in our y equals mx plus b. But this minus y1, the y1 stands for the y value from a coordinate point. Equals m, same m as our slope. X is just an x variable, like in the y equals mx plus b. And then x1 is the x value from our coordinate point. So it says, write the equation in point slope form of the line that passes through the point 4, negative 3, and has a slope of 2. So if I have y minus y1 equals m times x minus x1, my m I know is 2, so I'm going to right away put 2 in there. I can have an equal sign. Now, if y stays, y1 comes from right here. This is my y1. So I have to minus a negative 3. My x stays, but my x1 comes from my point right here, so I'm minusing 4. So the minus is part of the equation, and then if you're minusing a minus, that becomes plus. So I would write this as y plus 3 equals 2 times x minus 4. And that is the point slope form. We can leave it just like that. Pretty cool. Let's try another one. We have 2 points now. We don't know the slope right away, so we do have to find the slope first. So change in y over change in x. 12 minus 2 over 2 minus 7. So 12 minus 2, 2 minus 7. So 12 minus 2, that's going to be 10 over negative 5. So the slope is negative 2. So y minus y1 equals m times x minus x1. My slope is negative 2. I'm going to put that in right away. I can choose either of these points to use. I like to use the one with smaller numbers just because I think that's easier for me. So I'm going to do y minus y1. I'm going to take right here as y1, so y minus 2. And x minus my x1 is 7. So right here I have it in point slope form. And if that's all that we ask you to do, then leave it like that. But often you're going to be asked to convert that equation into slope-intercept form, our common form that we're used to. So all you do is you take where you have your point slope form, y minus y1 was negative 2, the slope m times x minus x1 was 7, and you're just going to simplify this. So first thing first would be the distributive property. Y minus 2 is equal to negative 2x, that becomes plus 14. And then I want to get the y by itself, so I'm going to add 2 to both sides. And of course, I'm putting it over here with the 14, not with the x, because the 2 doesn't have an x with it. So I have negative 2x plus 16. And there I am in y equals mx plus b form, or slope-intercept form. Pretty nifty. I think I have 2 more examples for you. So we want the equation, and we're going to have these 2 points. I'm going to start with the slope, change in y over change in x. So I'm going to do 36 subtract a negative 20, those are big numbers, and 4 subtract a negative 3, so that becomes plus and plus, so this becomes 56 over 7, and luckily enough that works out to a nice round 8. So I want to plug in the slope and one of these points into my point slope form. Y minus y1 equals m times x minus x1. My y stays as a y. My y1 I'm going to use as negative 20, so it's going to be minus negative 20. My m is 8. X minus, here's my x1, negative 3. That's an x. So negative 3. So that becomes plus 20. That becomes plus 3. So now I have y plus 20 equals distributive property. 8x plus 24 minus 20 from both sides. I'm probably going too fast. I'll slow down. 8x plus 4. 24 minus 20 is 4. So there I have it in my nice, comfortable y equals mx plus b form. Last example, it says write an equation of a line that is parallel to y equals negative 2x plus 7, but passes through 5, negative 1. Well, if it's parallel, then we know that parallel lines have the same slope. So my m is going to be negative 2, and my x1, y1 are going to be 5 and negative 1. So if I have y minus y1 equals m times x minus x1, I'm going to do y minus the negative 1, negative 2 is my slope, x minus 5. Well, that becomes plus. I'm going to do the distributive property. So y plus 1 equals negative 2x. That becomes plus 10. Negative 2 times negative 5 is a positive 10. Minus 1 from both sides. Y equals negative 2x plus 9. There it is. So we've gone from point slope form, slope has an E, down to slope intercept form. Thanks for listening.